This week's episode is sponsored by Audio-Technica.
You're listening to the B&H Photography Podcast. For over 40 years, B&H has been the professional source for photography, video, audio, and more. For your favorite gear, news, and reviews, visit us at bnh.com or download the B&H app to your iPhone or Android device. Now here's your host, Alan Weitz.
Greetings and welcome to the B&H Photography Podcast. My name is Alan Weitz.
And I'm Jill Waterman.
And as always, don't be surprised if our audio engineer, Mike Weinstein, hops on the mic with a question or a comment or two. You never know. While its exact origin is unclear, the celebration of National Camera Day on June 29th is a big deal for us here at B&H Photo because, after all, cameras are what we do around here. In this week's podcast, we're starting the party early by taking you back to what some refer to as ground zero of one of photography's biggest game changers. Exactly 50 years ago, Eastman Kodak hired a young electrical engineering graduate fresh out of Rensselaer Polytechnic Institute named Steve Sasson to work in the company's electronics group research lab. Given the simple directive to evaluate the possibilities of the newly developed CCD circuit, Sasson combined his passion for tinkering and a penchant for invention to build the first handheld digital camera. What transpired from there is a tale that attained mythic status over the years, and today we get to hear all about it straight from the guy responsible for transitioning the world of photography from analog to digital. Mr. Steve Sasson, welcome to the B&H Photography Podcast.
Thank you, Alan. It's a pleasure to be here. I'm a big fan of B&H Photo. I try to stop in the store anytime I'm in New York just because it's such a neat place to visit. So it's a pleasure for me.
Oh, in that case, we're going to waive the fee for having you on the show today. We're not going to charge you for being a guest.
Thank you.
And also, I think it's worth sharing with the world out there that we are both Brooklyn boys, born within a year of each other. So we have a deep bond here. This is going to be a very special show. So anyway, all that said, in 1973, you were fresh out of Rensselaer Polytechnic Institute in Troy, New York, and you were hired as an electrical engineer by Kodak up in Rochester. And this was unusual that until that time, Kodak really concentrated on hiring chemical engineers for their film and processing divisions, and electrical engineering was sort of a backwater division in many ways. Did you have any inkling at the start of what direction your career was about to take at that point?
Boy, not honestly, Alan. I didn't. When I interviewed at Kodak, I was most impressed by the diversity of projects and technologies that they were involved with, not only for the commonly known consumer products, but also they were involved with medical imaging. They were involved with government imaging and professional imaging as well. And so my interview there took me to visiting all of those locations, and I was just excited. I really had a lot of options in front of me when I decided to join the company, but I didn't know exactly which way it would go.
Interesting. Now, growing up as a tinkerer and then as a young engineer, you didn't have an interest in photography, but were instead focused on electronics and the relationship between silicon and light. Do you think your relative indifference towards photography was an advantage in that it allowed you to be a freer thinker, sort of outside the box during your early days at Kodak?
Yeah, I would imagine it was. I knew very little about photography. When you joined Kodak, any engineering discipline, you were introduced to the art and science of photography through several mandated courses that engineers had to take. So I had to take film photography and develop film and that kind of thing. And so I didn't know anything. I don't think I even owned a camera when I joined Kodak. So I didn't know much about this stuff. And so therefore, I didn't know what the good and the bad things to suggest were. I just thought, okay, this is a really interesting technology. Maybe there's another way to do it. So I think it helped a little bit by not being encumbered by the norms of an established technology with which I was well versed. So.
Interesting. Now, you were given this little device, this CCD, which nobody knew what the heck it was early on. They were literally handmade devices that was sent with some basic instructions and a little note saying, good luck, you're on your own here. Did you have anything in mind when you started looking at this little device and knowing that you want to see what it's going to do photographically? what did you have in your mind at that time? Any future vision? Or were you just looking at this saying, okay, well, let's just see where it goes?
Well, I was a junior engineer in an electronics research laboratory and an applied research laboratory, which meant we worked with all the equipment that Kodak was developing, usually in support of film and paper. And my supervisor, Gareth Lloyd, came in one day. I had just finished working on a control system for a lens cleaning machine, and that's how I got introduced to digital. And he suggested a little filler project that I could take on, and he suggested looking at this CCD, this new type of device. Now, I was predisposed to be interested in this because in college, I had done my master's thesis on an optically controlled thyristor system for regulating power in a motor stator. And so I was interested in how light affected silicon and electronics. So when I was offered this opportunity, I jumped at it. But there really wasn't much of a project plan. I mean, it was probably a 15, 30, maybe 45-second talk in my office. I remember as he leaned against my file cabinet there, he says, okay, get one of these things, play around with it, see if there's anything useful we can do with it. And so that was the total sum of instructions or indication of what I should be doing with it. So my object was first to start to get it to run, which was, quite complicated. It required a lot of electronic clocking signals that were a little odd, and no one had worked with this kind of a device before. So,
and there were no YouTube videos you could check out.
No, there was nothing. I mean, there was just a little diagram that came with the chip, and that was about it. But the idea of a camera sort of came gradually. But it didn't take that long. You can see the reasoning. If you get this thing to run, you're basically getting an exposure pattern of light on the surface of this chip, which is about the size of your thumbnail, and it would create a charge pattern, and you'd clock out this charge pattern if you could figure out how to do all the electronics to do that. And then I was supposed to measure it. Well, what's the best way to measure something? I says, well, turn it into numbers. So I thought I'd digitize it because I just finished doing a digital control system on a lens cleaning machine. So I was familiar with digital SSI, small scale integration. And so consequently, I said, okay, I'm going to turn them into numbers. That way I'll be able to measure it. But then since this device doesn't hold the charge very well, you have to get it out of there rather quickly. And I needed time to measure the numbers. I had to store the numbers. So I stored them in a digital memory. And then I realized I had a charge pattern that was corresponding to a light pattern that was exposed for a period of time on the surface of a device. And I had created an electronic version of an image. So I had a camera here. And so if I could just come up with a more permanent form of storage for this, which turned out to be a digital cassette, I would have what I called an electronic still camera. And then it occurred to me if I could build this camera with no moving parts. And that was strictly the Brooklyn in me, and you'll appreciate this, Alan. I wanted to annoy the mechanical engineers, which had a dominant position in the laboratory. I thought if I could build something with no moving parts, that would really get their attention. So I had no idea how to go about doing all this, but I decided this was a worthy thing to do because I was brought up in the 60s like you were, and I watched Star Trek, and I'm convinced all good ideas come from Star Trek. And you never saw paper or film on this bridge of the Starship Enterprise. Everything was electronic. Everything was instantly transmitted with lights and things. And so I thought if we could do photography without consuming anything, the only thing I would consume in taking a picture and displaying it would be a few joules of energy rather than a bunch of materials and chemicals, that would be an interesting way to look at photography and maybe a futuristic way to look at it. And so that was kind of my motivating factor for seeing if I could go and do this. Now, of course, nobody told me to do it. Nobody really spent a lot of time asking me what I was doing. So I had the freedom to experiment and to fail many times in the year or so it took me to build.
Personally speaking, I'm glad they left you alone to your own devices. I think you did very well with your time. Something I do want to go back to, you mentioned that's one of the earliest applications of this device was going to be for a thyristor. And when I hear the word thyristor, I automatically think of a Vivitar 283 flash. And thyristors were the original devices that enabled you to have auto flash exposure because they read the light reflecting off your subject after the flash went off and cut the flash so that it didn't overexpose. And that was a big deal. So you were actually working with a device that they were thinking more in terms of flash duration. Is that a correct assumption?
Well, the thyristor contact in my life was having to do it in my master's project. I love the idea of light controlling electronic devices. I don't know why. I thought that was cool. Maybe that was my Star Trek. I don't know. But I wanted to see if I could control a bunch of optically controlled thyristors in a rotating armature of a motor, and just do it with flashes of LED lights. So I could turn things on and off without any mechanical connection. And I ended up building a prototype. I actually wrote to GE in Pittsfield, and I suggested that as a poor college student, I would need some free devices. And believe it or not, they sent them to me. I couldn't believe that. And so I was able to build these things. So they were just high current devices that were controlled by optical pulses. And that's how I got interested in it. And I did some papers on that for another course at RPI. And so when I was offered this opportunity to look at CCDs, which was totally different, CCD is a transducer, is a device that turns a light pattern into a charge pattern. And then that charge pattern is collected in things, we call them pixels, but they're really local areas that have a charge depletion well where they could just store them. And then the CCD capability, which is developed by Boyle and Smith in Bell Labs in 1969, they developed a way to move these little charge packets, which represented little local areas of light intensity, off the chip in a very precise manner. They didn't lose any of the charge or gain any of the charge in the time it took them to get it off. And so that was the CCD mechanism. And Fairchild had made this device, which was an area device, a 100 by 100 array of these photosites that used this CCD technology to get the charge patterns off. It was very obtuse to run it, but it was a very interesting device. And this was the device that I was able to buy and to turn into a photographic application in the lab.
Steve, I'm curious about the tape that you used for the storage of the visual information. Was that just like an audio tape?
Well, yeah, it was. It was, Jill. You could buy, at that time, this was in 1974, 75 timeframe, people were storing digital information for the precursors to personal computers on these cassette tapes. And I needed a more permanent form of storage of a digital file. I couldn't just store it in the DRAM because the DRAM required power to be on. And I knew that anything I would put together in terms of a photographic system, which is what I was trying to build, would be compared to a film system. And film had a tremendous reliability in terms of storing images. Film is a wonderful technology because not only is it a transducer, but it's also a storage device. But the CCD is a terrible storage device. So we digitized it, stored it in DRAM. We did that rather quickly in order to keep the integrity of the charge pattern. But then I had to store it in something more portable and permanent. And that's why I used the cassette tape. And that's how I ended up using that. So I sort of missed my goal of not having any moving parts because that thing definitely moved. But it turned out to be a very reliable way. I didn't want to lose any image that I got. I did not want to ever lose it because that would undermine the perception of the integrity of this system.
Do you happen to remember how long it took to save, for instance, your first 100 by 100 pixels?
Yeah, the picture was captured in 50 milliseconds. I had a 200 kilohertz rate on the horizontal shift register, and I digitized that using a new form of A to D converter that just, lucky for me, it just came out around this time. And then it stored it in memory. So it was captured and stored in 50 milliseconds.
Right.
But to store it to the tape took 23 seconds. And I could have done it faster. But I wanted to make sure I had a very crude form of NRZI encoding, and I put a stop bit between each bit, just so I was trying to make sure I didn't lose anything.
Right.
So I could have done it faster. How much faster? I don't know. It could have been it could have been maybe half that speed.
Yeah, shaved a couple of seconds off. But
you
wanted to lock down this idea that was germinating, it appears. This is a digital version of a camera, and it needs to have high fidelity to the actual signal from the DRAM back to the tape. That's a paramount kind of thing there. Yeah.
I didn't have any error correction or anything like that. So I had to make sure, again, whatever system I came up with, I wanted it to work. It may not work well, and the image quality may not be good. But when I decided on the camera approach, then I realized I had this stored image in a digital format on a tape. But then I said, well, what good is that? I can measure it, but wouldn't it be great to look at it? So I had to build a whole playback system as well. And that was the other half of the project. Nobody really talks about that too much, but that was a big part of it as well. And there I pressed into service one of the first microprocessors because I had to do image processing. Because I only had 100 lines of image information, and the only electronic device I could use was a television set. And so television sets had, for NTSC format in the United States in the 70s, it was about 490 displayed lines. I could say I could get to 400, which is I have to go from 100 to 400 lines. So I had to do some duplication and interpolation. And so I needed a mathematical thing to do that. And so I talked the lab into buying a microprocessor development system. Totally a lie, by the way. I told them I was going to do microprocessor research. And they said, oh, that's a good thing for electronics guy to do. I wasn't doing research. I was building a playback system for this camera. I had the hardest time visualizing this thing because I had to build all this custom electronics that would fit in with this microprocessor. And so I had to buy a development system, and they had a bus system in there. It was called New Bus at the time. And I could buy boards that I could plug in there, and I built all my electronics for taking in this digital information, storing it, rearranging it, and then creating a television signal. I had to do all that on these boards, but I had to talk to this microprocessor. It was a Motorola 6800 at that time. And so this goes to a point that I think I should make, and that I stole most of the stuff I used to build this. This was not authorized by anybody. This was just a project to keep me out of trouble before something useful came along. Now, Alan, you'll remember this. In Brooklyn, everybody used to throw away their old TVs and radios.
Absolutely.
And I used to go around all the time and pick these things up, drag them back to the house, and then do an autopsy on them, pull out all the capacitors, resistors, transformers, and then I would leave these carcasses in my alleyway in the back. And that was a kind of an annoyance to the neighbors. But
we did that with cars, by the way.
Yeah, cars too.
That's just between us.
I got a story I could tell you when we're off air about cars. But the thing is that I sort of adopted that approach here. But I was in the greatest place in the world to scrounge parts. I was in Kodak Apparatus Division, which was a manufacturing facility as well as a research area. And so when I needed a lens system, I went downstairs and stole the lens assembly from the manufacturing line for XL movie cameras. When I needed a tape system, I found it in the back of a magazine, and I ordered it. It was a well logging tape system. And I ordered it, and it came in, and it would fit into my box that I would use it to record the images. And a lot of the electronic parts I either grabbed from the laboratory stores or I ordered special, but they were so low cost that nobody noticed. That's kind of how it all, happened.
That's interesting. I'm wondering, Steve, do you think your manager and other people at Kodak were aware of programs like what was happening at Xerox, for instance, where they had people, just doing stuff, and perhaps that would lead to sparks of genius and invention at the end of that?
Well, I don't think anybody considered this a spark of genius at the time. My supervisor, Gareth Lloyd, was really an unusual and gifted guy. He knew when to let go. And he could see that I was having fun with this thing, but he didn't really ask me too much about it. Nobody was really, it'd be nice to see the results, but nobody was depending on the results. And so I would sit with him once every 2 weeks. We would have a little sit down just to see what's going on. And I would tell him a little bit about what I was doing and also what I was doing on the camera. And the outstanding thing is a memory I have is when I finally got it working in December of 1975, I took my first image. I was all excited, and I went into his office and I told him, I said, my camera, it's working. I took my first picture. And he says, great. He says, we should get the head of our laboratory and bring him into your laboratory and show him. I says, no, it's portable. He didn't realize I was building a portable camera. So, the discussion was sort of distant. We were talking about technical details and everything. We weren't talking about a whole system and how it might be applied and things like that. So I was very lucky working for him because he was kind of tolerant, and he also let me go with this thing. And he also helped me when I had to present it to the rest of Kodak. He was very helpful as well. So I was lucky not only working for him, I was lucky being in the research laboratory, and I was also lucky working at Kodak in the apparatus division where I could get a lot of stuff for free.
I would imagine that because this division that you're in, there are a lot of people with eclectic specialties that were basically put together to just work on different ideas, and you could bounce off of each other. Did anybody else start sharing your vision about this camera as you were developing this thing? People who had maybe other specialties, interest specialties, where they came home and say, why don't you try this? Have you thought about that? At what point did other people in your group start coming in and like poking their fingers at your experiments?
Well, what I was doing, I wasn't sure this was ever going to work. Okay. And so I'm a brand new engineer trying this crazy thing. And I wasn't really, going around broadcasting I was doing this. But I did talk on a technical level about different systems to, you're right to point out, there were many experts in different areas. There were experts in optics. So I asked them about what would be a good optic to try. And I knew that all I had to do was fit this active area inside the film plane of some existing optical assembly. And so, they helped me select those. There was a lot of analog electronics that was involved here. A lot of people don't realize that the whole system was digital. The imaging chain was all digital. But to get the imaging chain to work required power supplies. It required clocking systems and analog voltage thresholds that had to be driven to the CCD. Luckily, my roommate was an analog expert. His name was Greg Moberg, and he would talk with me about a good way to do this circuit or that circuit. So I would take different technical pieces and talk to different experts about those things to get their ideas about how to solve a particular problem. But I've spent almost no time talking about the whole system to anybody because it wasn't really crystallized in my mind either. I just said if I could just see a picture, I'd be a happy guy,
Mm-hmm.
Now, once you started seeing pictures and saw that there is something here that's worth pursuing, and I'm assuming that this happened, at what point did you start getting little cockeyed looks from upper management saying that this could rock the boat? Because let's face it, you're dealing with a company that is about chemistry and film and all the things that follow up. The camera is only the starting point because Kodak made their money from all the things afterwards, film, processing, prints, and all of the output that we have from that. And now you're coming up with a product that could seriously impact that piece of income from the company, because with digital, you don't necessarily need processing. You don't need prints. It killed a lot of the future, money.
Oh, absolutely. The presentations of this system took place in the winter and spring of 1976, and they were all pretty much the same. My laboratory was the cleaned out back lab. It was a lab nobody wanted, so we cleaned it out. The fellow who worked with me, by the way, was Jim Schickler. He was a technician that worked with me shoulder to shoulder, getting this thing to work. And he and I would be in this back lab, and when we had a demonstration that was set up by my supervisor or by the lab head, you can imagine an organization as big as Kodak at that time was a very large corporation, have many layers of management. And so anytime you introduce something like this, which, is a little disruptive, you sort of go to the next level. And then once they get comfortable with it, then they tell their people above them, and then they tell people above them. So all throughout the winter and spring of 76, I did a demonstration in the conference room of our laboratory, which was 10 feet long, and people would sit on either side. It was a windowless conference room. I walk in, and what I would do is take a picture of the person who was sitting in the front seat on the right side. And I would just hold the camera up. It's like the size of a toaster. And it was an odd looking thing. And I would just take their picture. And I knew the picture was being captured by virtue of the tape would start to move. That was my indication that I had captured an image. And then for 23 seconds, I would try to explain to people who didn't know what this thing was. And then when the tape stopped, I knew I had captured the image. I would take another image of a person sitting on the left side, head and shoulders, same thing. And after the tape had stopped recording that one, I would put the camera down in the middle of the table, pop out the tape. It was a Phillips cassette, and I would hand it to Jim who had brought our playback system, which was a microprocessor development system, on a cart with a television set on top of it. And we would plug it in, and 30 seconds later, 23 to read it in and 8 seconds to do the interpolation to get it suitable for NTSC format, the picture would pop up. That was the demonstration. Now, I got to tell you that I was totally unprepared for the reaction that I got. I had spent a year or so trying to figure out all these technical tricks and using technologies and merging them together. They never worked together before. And I thought they'd ask me all about the technical tricks I used, the how I did what I did. They didn't care about that. They asked me why.
Ooh, wow.
Why would anybody want to take their pictures this way? What's wrong with film photography? My God, there's no prints. What would an electronic photo album look like? You know, not to mention...
The obvious question.
Well, they're good questions, and I had spent zero time thinking about it.
Right.
And that was not your job to think about that. They hired you to experiment.
Well, it was just like I was all ready to answer all these technical questions, and that never came. They didn't know who I was. I mean, I'm 25 years old. Nobody had heard of me before. You know, I was relatively new at the company. But they were impressed. This was a cool demonstration because it was a complete photographic system. I was taking pictures and I was displaying them. And so you would have people argue with me that it would never work while their picture was staring at them from the screen that I just took. You know, it was like, well, this can't work, right? You know, kind of a thing. Now, the pictures weren't very good. They were black and white. I didn't know how to deal with color. And I was asked all kinds of questions about next steps. And the one I was asked all the time was when this would be available for consumer photography, because my pitch was that this would be used for consumer photography. I would have been much smarter to pick a more niche application and just focus on that. But I was really dumb. You know, they would send me a list of people, none of which I knew, and I was supposed to send out the meeting notice to them, and I entitled it Filmless Photography. Ooh. That's what I called it. Bad choice, right? I mean, given the audience, right? So I wasn't really thinking about how to introduce this idea. I just thought it was kind of obvious that this was kind of an interesting way to take photographs. But I didn't think about how much time it would take to get mature. And I was asked that all the time. So I used Moore's Law to estimate. And I estimated a million pixels would make a satisfactory image with color. So that'd be 2 million pixels. The research lab, I called the research lab and asked them that question. And they said 2 million pixels if you want color. And I was just trying to get as good as 110 film, you know, not the high watermark of photographic technology in terms of image quality, but I was desperate. And so I used Moore's Law, not knowing if Moore's Law applied at all to CCDs because they really weren't the same technology that Gordon Moore was thinking about when he was thinking about integrated circuit evolution. Yeah. But who cares, right? I'm desperate. Anyway, it came up between 15 and 20 years. And it turned out that was a good estimate for all the wrong reasons. You know, we introduced our first digital consumer camera 18 years later. But I had no idea of all the things that had to really take place in order to make that estimate come true. I was just kind of desperately trying to throw a dart against the wall to see when it might happen.
Was going to a consumer market something that was on the table initially? Was that what most people envisioned up front, or was it a combination of consumer and technical applications of this new technology? Because I'm getting that it seems to be consumers were right up there from the get-go. That's what I'm hearing.
Well, the people that were invited to these meetings, and like I said, there was about 10 or 12 each meeting, and there were many, many meetings. And I didn't know who they were, but they did come from different parts of the company. Now, Kodak, like I said before, was a very diverse company, had many, many markets, professional market, consumer market, medical market, business market. And so they would come in and they were representing their interests. So their questions always centered around their business. For example, the people from business imaging systems, I'll never forget this. I carefully arranged it so my camera would take just 2 pictures, and then I would put down the camera, and hopefully I wouldn't have to use it again because it might not work, right? This thing was not reliable at all. But a fellow, I remember he stood on the back of the right side after I was pitching. He stood up and he took a check out of his wallet and he slammed it on the table and said, "Take a picture of this." And it was a blank check. So I did. And I remember being nervous. And fortunately for me, it worked. And up popped the picture on the television set of the blank check. And he walked around the table and he stared at the TV set, like 6 inches away from the TV set. I don't know. People like to do that when they see bad pictures like this. But he looked at that and he said, not enough resolution, which was evidently really true because it was only 100 by 100, so 10,000 pixels. But then he turned to the other people in the room, whom I didn't know. And he said, this thing works better than a whole room full of equipment I've seen anywhere else. And so it's like, okay, I struck a chord with this guy. I don't know who the hell he is or what he's doing. Right. But it was an example of the people who came to see this viewed it from their market perspective.
Right.
So I had professional imaging people that really were upset with the image quality. Consumer was really upset about image quality and cost and size and everything else. They were constantly asking me about, what's the photo store going to be like? Why do we need photo stores? And stupid me, my answer was, well, they could sell batteries. Not a good answer, not a good answer. So I was really ill prepared for these demonstrations. But luckily, my supervisor, Gareth Lloyd, after every presentation, he would come into my office and give me some pointers on how to better present what I just did, right? And so I got a little on-the-job learning about this. And he also chimed in the meetings to sort of, define it in light of their business, because he was much more experienced than I was. So I had help there. But in a large part, I was very unprepared for the reaction.
I'm just curious, Steve, if there was any thing that you can pick up from Kodak writ large regarding the fact that, these CCDs are out in the wild. There may be other R&D labs, corporations that might be testing. And what you're coming up with is rudimentary, but if it was sophisticated and feasible, it could be something that was, concerning perhaps. Was the corporate climate such that there were any ideas about this thing happening elsewhere in the world and them getting to it first?
It's a good question. In 76, there was no talk about this going place anyway. The only examples of industry developments, I referenced some of the stuff going on in the microprocessor world. My playback unit, they were asking me, how can a consumer afford something like this? And I was thinking about how that might be done. And Wozniak had just proposed a new type of board for the Apple computer. I saw it in a magazine. He used the same DRAMs I used. Mm-hmm. And I thought, well, maybe we could build a board like these guys are going to build, because they had a microprocessor chip on the board with this little DRAM. So I used that as a possibility, not an exact draw. So I used industry pieces. I used the HP 35 calculator, which had just come out. And I said, well, think of this as a calculator with a lens, because I couldn't think of a consumer product that was based on digital. And there was no consumer digital products. It's not only what you're doing, it's how you're doing it that impacts the reaction you get. And the reaction I got was, I was suggesting this as a new type of photography for consumers, but it was based in digital technology completely. And there were no digital projects. Digital had a sort of a bad reputation at the time, in terms of complex, expensive, esoteric kind of thing. And so I had to find something that was like that. The HP calculator, I said, calculator with a lens. Think of it something like that. I was desperately clawing for little analogies of things I was seeing and saying this could merge to something in the future. I had no idea if that was going to happen. But the only time it really hit the brakes on Kodak was in the early 80s when Morita at Sony told some of our managers that they were going to come up with a new form of photography, the still video floppy kind of thing. And he put it out in 81. And that's when I saw that the company started to really invest in this. Up to that time, it was sort of like, oh, that's interesting. Go in the lab, play with it, don't tell it to anybody, and that'll be fine. But now, when Morita suggested that they were going to go after consumer photography with their still video floppy approach, I was excited because, quite frankly, when somebody else like that says something, then they pay attention, right? And the other part of it was that Sony's approach was never going to work. I did the analysis on that. It technically had some fundamental flaws to it in terms of image quality that they were never going to get around. And Sony and Canon in the 80s were stuck in the same paradigm that Kodak was stuck in. They were so used to the technology, they just thought, I'll adapt what I know the best. And I'll make it work. And they were going to make television and video. And we knew that this was going to evolve around the computer. So that's why Kodak started developing megapixel sensors before anybody else did.
Do you surmise that Sony had done some R&D with the CCD stuff before Morita made that announcement?
Yeah, they had a prototype, I think, and they showed some people in Japan. I talked to one of the managers who came back, and he said, yeah, he showed us this thing. He puts this little 2-inch disc and it records a field of video or a frame of video. At the time, I think they only had a field working. And they used the CCD as the sensor. Right. So they used the CCD and they kept it in an analog waveform and they converted it into a television signal. It really wasn't a television signal. It was a modified version of a television signal. And they recorded it on a magnetic tape using like VCR technology, but it was really a different type of encoding. It was called FM color under. And it was their attempt to come up with a way to take the technology they were familiar with and put it into a new type of product called a still picture camera using still video floppy material.
One thing that comes to mind for me is that you're talking about the earliest applications and how people envisioned these new cameras. And it's impossible not to think about the original Foveon camera, which was literally a laptop with a lens stuck on the front of it.
Yeah, right.
And it was not exactly the most conducive to taking pictures, but that's how they envisioned it. It's going to be through a computer, so let's put a lens on this thing and we'll use that as the camera.
Foveon went for the 3D type of imaging sensor. Different layers of silicon would capture that. And they were trying to mimic film, basically, which is how film is organized.
Right.
But most of the imagers were depending upon a single plane matrix approach to the pixels using the Bayer array. Bryce Bayer, by the way, worked at Kodak, and he was the guy that came up with the first patent associated with taking different color filters on a matrix and combining them into a color signal so that your eye couldn't see. Yeah, one of the interesting things in development and innovation is in existing companies, when they see something new, they try to take what they know and sort of bend it to solve the problem, okay? Kodak didn't know much about electronics, certainly not in the imaging chain at the time, but they knew a lot about the problem to be solved. Whereas Sony and Canon seemed to know a lot about the technology, at least the present day technology for doing video, but they didn't know how good the image had to be and how it would work. So knowing more about the problem turned out to be an advantage to Kodak because we took the right approach, in my opinion, in the early 80s when we started developing bioarray megapixel sensors and trying to figure out how to build those things cheaper and easier. We still didn't have the digital technology. We had to leverage that off of existing parts. But we started down the right road in the early 80s.
Steve, I'm curious, when you were talking about the Sony's early announcements about doing research, were they at that point in the early 80s aware of what you were doing?
No, I don't think so. At the end of 76, I wrote a technical report. One of the groups I demonstrated the camera to was a bunch of patent lawyers, and they sent me a letter afterwards asking me to write up an invention disclosure, and we filed for a patent. And a patent was granted in 1978. And when a patent gets granted, back then it became public. And so all you had to see was Eastman Kodak and electronic still camera, no film. And people got interested. So they started calling me up. And I called my public relations department because Kodak was a pretty tight-lipped company about research stuff.
Right.
And I said, I'm getting calls about this thing because my name was on the patent. And they told me in no uncertain terms that I was not allowed to talk to anybody about this work in any form, and any requests I get for information to send it right to these guys. They gave me the name of the guy and everything. And so ever since then, I never spoke publicly about any of this work until the year 2001. And that was because at that time, Kodak was happy they invented the digital camera. And it turned out I had kept the prototype, which, again, this is the Brooklyn in me. That was illegal. I shouldn't have done that because you're supposed to destroy all of these R&D funded things.
But from Brooklyn, that's a minor technicality.
It was a minor detail. I figure I would lose it. I lost it several times as I moved offices and stuff. But I kept it because it was just too cool to get rid of. And so they said, if you still have it, bring it. And I remember calling up public relations in 2001 saying, okay, guys, you told me I shouldn't talk about this ever. And so now it's 2001 and they're asking me to talk. And so, okay, it's good to talk about it now because it's helpful for us. So the first picture of me was taken by a Democrat and Chronicle photographer. I think it was in October of 2001, holding the camera.
That was also an apogee for Kodak in many ways, because I remember at that time I was working for a place called Photocare in Manhattan, and we were very, very upfront with a lot of the digital equipment that was just breaking into our new world. And I spent a few days up in Kodak. It was early 2001, I believe. And we went up there. This is when the DCS 760s were the camera. And that was an amazing machine. And Kodak was getting out of the camera business at that point. Kodak used to make phenomenally great cameras with German lenses, and they were built beautifully. And then they got out of it because I guess there wasn't as much money. They was just better to just sell film and make prints. But all of a sudden, you're now taking Canon and Nikon cameras and essentially hacking them to become digital cameras. And for 2 or 3 years, Kodak, they owned digital. They had the 35 millimeter camera, which is actually an APS-H sensor. It had a 1.3 factor on it. And they also made the Pro back for medium format cameras, Hasselblads, and it was a medium format back that took micro drives and had an LCD on it, which was just mind-boggling back then. And you guys wrote it for a couple of years, and then it just vanished. It disappeared.
Yeah. Yeah, many of the cameras you just cited were developed by the professional camera division, which was really, you went to the professionals. Well, first you went to the government because they're the only people that can afford prototypes. But then after that, you went to the professionals because they would pay a ton of money for a brand new camera if it allowed them to get an image back to their publisher in a few minutes. Mm-hmm. So that was all developed by a camera group headed by a fellow named Jim McGarvey, who consolidated all of the resources in Kodak, and they became Kodak Professional for digital cameras. Nikon was the first bodies I think they used, and they never talked to Nikon. They just bought the cameras and cleared them out and then made them digital, right? And then they would launch them because professionals were comfortable buying something that said Nikon on it, right?
Right.
And so the first few versions of them were just Nikon, and then after a while, they started putting Kodak in bigger letters on the Nikon cameras, and then they shifted to Canon as well. And they were always using those bodies because we didn't make those camera bodies anyway. And so it was sort of a nice marriage.
You're saying that when they were doing this, they actually never really conferred with those companies about doing this?
Yeah, as I talked to those guys, when they launched these things at the shows, Nikon saw them for the first time. in the early days,
That's crazy.
Well, we were the only people, in the early 90s, Kodak was really the only place. We were sort of caught between a rock and a hard place. We knew the most about how to do this and how it was going to progress, but we didn't like the answer. Okay. Mm-hmm. So we didn't really advertise it too much. But like, for example, the first camera built for Apple computer, the QuickTake 100, that was designed and built by Kodak, but we weren't allowed to tell anybody about it. It had the Apple name on it. And they came to us because Apple was looking for an accessory to be the input device for the Apple computer, which was turning out to be the imaging computer in the early 90s. And so they came to us, and our management said, yeah, you can build it, but two things. One, you can't say Kodak on it, and two, it can't look like a real camera. If you take a look at the QuickTake 100, you'll see it looks like a binoculars, and that's very deliberate to do that. So again, we knew the most about it, but we didn't like the answer. It was going a little bit against our grain because the image quality wasn't nearly as good as film. Film was progressing, as you know, during this period, T-grain emulsions and stuff like that. So you had that problem, and you also had the business problem. What's the business model for these things? You sell somebody a digital camera. One, you have a training hill to climb with people. Two, where's the recurring stream? There's no film, there's no paper. So the whole business model was uncomfortable. And clearly, when you talk to marketing people, that's one of the first things they ask. How are we going to generate income from that?
So instead, they turned around and they started selling the same technology to other companies that took these sensors and created better software to get better imagery out of it and essentially buried Kodak. So they were buying the hardware from Kodak, improving upon it, and just basically stomping out the originator of it?
Well, this happens, yeah. If you were Nikon and Canon, where do you make your money? You make your money off of lenses, accessories, and things like that. And we didn't make any of that stuff. So, staying in that business really didn't give us a good return. It offered us a nice technological platform, and we could be viewed as real pioneers and trendsetters in the industry. But, kind of show me the money kind of thing.
All right, we are going to take a short break for traffic and weather and whatever else you might want to do. And we come back more with Steve Sasson and the original digital cameras from Kodak. Stay tuned.
Designed with content creators in mind, Audio-Technica combined the studio quality of their ATH M50X headphones with the clarity of their 20 series microphones to create the professional ATH M50X STS stream set to fit the headset needs of serious gamers and streamers. Whether you're podcasting, gaming, or on a studio-based production, the ATH M50X STS stream set provides outstanding build quality and field-tested audio performance, and it's available in XLR and USB versions at bnh.com. Learn more about Audio-Technica products at bnh.com using the link in our podcast show notes.
Okay, we are back with Steve Sasson, who is the creator of the original digital camera when he worked at Kodak. Something I'm curious about is that I mentioned earlier in the show that Kodak at one point was known for making extremely good cameras. They were built like tanks. They had German glass on them. They were just really, really fine cameras. And then they got out of that. And in the meantime, now digital comes along and they need cameras to go along with this new technology. Do you know if Kodak was considering getting back into the camera business at this point since they had this new technology? Or did they just figure, let's just take what's out there and hack it?
Well, I will tell you, since 1976, I worked exclusively in digital my whole career at Kodak. And so I wasn't really privy to a lot of the planning on the silver halide side. However, I knew a lot of people that were. And it seemed to me that the only reason Kodak made cameras was to support the introduction of a new film format. Okay, 126, and then followed by 110, followed by APS. In order to introduce a new film format, which was an industry-wide kind of a thing, it required you to make all the equipment necessary to do that, not just the photo finishing equipment, but also the cameras themselves. But the cameras never made a lot of money as far as I could tell. Like the disc camera, for example. They made millions of them, but I don't think that was a big moneymaker. The money was always in the consumables. Mm-hmm. So to your point, I think cameras represented the gateway to a new film format.
Except this time.
Well, this time there was no film format. So,
right. So perhaps they might have been thinking slightly differently about it.
Yes, they leveraged all of the existing platforms, the Nikon, Canon. There was Chinon. We leveraged some of their technology. But in the end, for the professional cameras, if we were making them, it just didn't make any sense for us to tool up to make the whole body. Okay, because it just wasn't enough of them being sold, and marketing wasn't that excited about it in the first place because of the money situation. So they walked away from that. Consumer was different. Consumer now was all done overseas. I don't think we made any digital cameras in Rochester, New York. Mm. I may be wrong in that regard. Maybe very early we did, but I think for the most part, we leveraged our relationships with Japanese manufacturers. And we were competing now with Sony and Canon and things like that for market share in the United States. And we did reasonably well for a couple of years.
This is post 2001?
Yes. This is like where they came up with Easy Share. The development of digital photography was an interesting thing because for film photography, Kodak sort of had their foot in everything. Everything from the papers to the machines that developed the film and paper to the cameras, everything, right? But when it got to digital, when you took a picture with digital, you took a picture on a camera made by somebody, storing it on a memory card made by somebody else, loading it to a computer made by somebody else with software made by somebody else. And then if you wanted to print it, you print it on an inkjet printer or a dye sublimation printer made by somebody else. We used to call it making a print with a digital camera, the chain of pain. But usually the consumer would blame the camera manufacturer if it didn't work out, right? And so this was the issue. There was very little money in the cameras. And I think Kodak dealt with a negative revenue or a negative profit situation for consumer cameras for several years before they got out of it. Because they wanted a presence there. And they were hoping we could lock people into systems. That is, a camera that would sit on top of a printer where you could charge it and it would automatically download it and make a little print and things like that. They're trying to simplify the process, part of the history of Kodak. You know, you take the picture, we do the rest kind of thing. They were trying to follow that kind of thing. But it turned out it wasn't really necessary because so many people were playing in this field.
You mentioned the fact that Kodak, they could build these new cameras, but after that, it's like, where's our money? Because there is no film, there's no processing, there's no prints. On that note, Kodak was very much involved in inkjet technology as they were also developing these cameras. And while the colors were really, really nice, they didn't last very, very long and never really caught on. Kodak did not have the range of inkjet papers, say, that Canon and Epson had. And the prints just were not quite ever the same. They never hit their mark on inkjet. And I think that was also part of the problem for Kodak, is that you couldn't take it past that because everybody else's products were better.
Well, this gets into the printing, the other end of the imaging chain. And I was involved with the development of the dye sublimation printers in the early 90s. And this was a technology that Kodak preferred for prints. The dye sublimation was a ribbon-based technology where you would heat up a dye with a linear print head, and you could make 300 DPI full-color prints. And they were really good. It was slow. And that's the technology we wanted to use. Then inkjet started coming along, and inkjet is inherently not really a great imaging system for consumers because, quite frankly, there's a whole bunch of water that has to be transferred in order to do D-Max blacks kind of thing. So we really didn't get too excited about it, but then we saw that the market was heading that way. Again, it's a cultural issue inside of the company. If the company had spent the last 100 years trying to convince people that we make the best quality photographic prints, then it's hard to walk away from that when the customer really doesn't demand that. Mm-hmm. Okay. And so the customer said, I don't really care if it lasts 100 years. Just give me a quick print. So dye sublimation represented a much more robust solution, but it was more expensive and it took longer. And the equipment was more expensive. And then you had other players like HP and Canon in the inkjet field. So it was only until Antonio Perez became our president. He came from HP, and he was the HP guy that led their inkjet development. So we thought he would come in, and Kodak had a new type of ink that they were trying to use. And we got into the whole business of trying to make printers. And I remember having several discussions with him about that, and as well as George Fisher, because it was a whole new approach to doing this. But it didn't work out very well because we just couldn't make the money off of this. They liked it because obviously ink is much like photographic film, very profitable in one aspect, right? Mm-hmm. The materials. Yeah. And so we thought we could do that, and this is just my opinion now, so I could be wrong, but I think we just got there too late. I mean, it was just too late. And it was something that was dominated by two other big players. And even though we tried a different approach to getting it into consumers' hands, they just weren't interested. In addition, there were growing pains to making good photographic prints with low-cost inkjet printers. It's hard to do.
You know, I get exactly what you're saying, because I remember that when Kodak started coming out with their papers and printers, one of the first things I would do is, because I was very active in that at that point in time, I would compare Kodak prints to what I would get from an Epson or a Canon. And that was my measuring rod right there. Are you at an Epson yet? Because Epson to me was the best out of all of them. And something else I want to talk about is your first digital camera. It was the size of an 8-slice toaster and looked like the inside of a vending machine. It was not exactly what you would call, a svelte device. And in 1989, you were part of the team that designed the very first DSLR. Could you tell us about that? Was it a Canon or Nikon camera? How many megapixel? What was the crop factor? What kind of camera was this?
Well, there's a little story behind that. It was called eCam, and it was functioning in 1989, and it was based on a DSLR architecture. And we built a handful of these. But it really started many years before that, one of the big challenges we saw in the development of digital photography was we knew that you had to have millions of pixels in order to get close to the performance of film. But millions of pixels take up a ton of room. So we had an advanced activity with many world experts in image compression at Kodak. And so we wanted to come up with a way to get this image compression, all these fancy algorithms, out of the lab. And so we proposed a product in the consumer electronics division that I was working in at the time to try to get an image compression product to compress an image by a factor of 8 to 10 and to transmit them over telephone lines. And so we came up with a transceiver type device. And I worked with a very brilliant research scientist called Majid Rabbani. And when we asked Majid which one of the probably 20 to 25 different algorithms under consideration around the world for image compression of continuous tone images, he said, use discrete cosine transform. And when I looked at it, I said, this is like really hard. You got anything easier? And he said, no, that's not my problem. You wanted the best one? This is the one the world will decide on. And he was right in 1986. He said, this is the one they'll decide on. They don't know it yet, but they will. Because again, we knew the problem. Okay. And so we developed this. We used Texas Instrument parts. There's a whole story behind this product. And this product went out. Nobody knew we marketed it until CBS News used it to get their pictures out of the Tiananmen Square uprising. Mm-hmm. And they shut off all the output, but they could transmit full images over that. And CBS News was so excited about this product that could send a full color image over a standard telephone line in under a minute. And they were the only people to get images now of Tiananmen Square because of the government crackdown. They wanted to do a television advertisement for it saying how great it was. And they went to Kodak and they said, we want to tell the world about this great product that you made.
I know where this is going.
And the answer is no. No. Management said, you can't, no, we don't want that. And so we had a really clever guy named Brad Paxton. He didn't grow up in Brooklyn, but he should have, because he talked him into it by saying, well, let them do it, but we won't mention the word Kodak or anything like that. And they renamed it. They called it the Magic Box. And they did this, I would say, 90-second little story about it. But he got Kodak up because it showed on the splash screen of the monitor. And so then our management realized that we had put this out there in a very esoteric market. Nobody was going to buy this stupid thing. We didn't know if anybody would. It was really a technical exercise to see if we could get all these image compression science into something that was small enough to sit on a desktop. And so this transceiver was that. It actually ended up winning an Emmy, I think. And it was a pretty successful product. We didn't expect it to be. But what we were really trying to do was set the stage for what we called eCam. And I went to a guy, his name was Robert Hills, and he was a camera designer at Kodak. He had designed every single camera film format in existence. He was an older fella, Scottish guy, and pretty opinionated about stuff. And I said, we want to build a camera. And he looked at me, and I remember he said, Sasson, he says, I'll build your electronic camera. He says, but it's not going to be one of those stupid things that you build. It's going to look like a camera, act like a camera, and be a camera. I'm not involved. And I says, okay, fine. So he knew the people at Chinon, and we stole parts from Chinon, and we built about a half a dozen of these things, and they looked just like a DSLR. They were a DSLR. We took one of the 1.5 megapixel imagers that were being produced at Kodak, on a limited version, of course, but they produced that. We took the image compression algorithms that we had worked out for the transceiver I just described. So we could take that 1.5 megapixels, compress it down without losing any valid visual information. And then we stored it on a little memory card. I think they were Samsung memory cards or Hitachi memory cards. And then we went to marketing with this. And these were operational in 1989. They put pretty good color pictures, Bayer filter arrays on them. And we went to them and we said, could you sell this? Because we just built a half a dozen of them with a small team. And the marketing guy said, sure, we can, but we won't. Why would we? Why would we? So I think that was the first time, from a technical point of view, we offered a solution that was sellable. And they didn't want it for business reasons. And so there was pushback on that. And then McGarvey took over, and his team, a lot of the team that worked on eCam went over to McGarvey's team. He combined it with other groups of people because there were many people working in this technology at the time. And he found that the government was very interested in this technology. And they would pay a lot of money for some of these kind of experimental devices. And then they moved it into photojournalism, and that's when it started really going. But we ran into cultural problems. You understand, like Ecamm had image compression built in, and there was no analogy to image compression in film photography. So when we explained to the photographers that indeed we were capturing 1.5 megapixels, but we were throwing away about 80% of that digital data because it really was redundant and you couldn't see anything, they were very uncomfortable with that. Because when you had a negative in your hand, you had all the information that could ever possibly be captured in that scene, and you never lost it. And all of a sudden, these electronic guys are throwing away stuff like it doesn't matter. And so the very early cameras always had to have a switch on it, as I remember, where you would switch off image compression if you wanted to do real photography. But you could only store 2 or 3 images on your storage device. So in addition to the business issues, there were cultural issues that we had to get past because of our history.
Yeah. It seems like Kodak was uniquely oriented against this stuff from many different aspects of it, especially the one you referred to just now, the idea that quality isn't paramount in some way.
Yeah, that was the problem.
Which digital technologies, they can do both. It's like a magic trick. You can do compression, which you don't really notice, but it's hard to explain that to people.
It was uncomfortable in the beginning. It got used to it pretty quick because the advantages were pretty good. But it turns out that the public also changed their view of photography. Instead of a way of memorializing an event with a beautiful image, it became a form of casual conversation where the images were throwaway. You just send it to some, especially with the advent of phones and things like that. It became a form of communication, casual communication. And so having absolutely pristine images wasn't that important to the average customer, just as long as it was good enough.
Well, I guess that also explains why the popularity of a lot of the Fuji Instax cameras. The pictures are terrible at them, but they're novel because they're unique and they're small and you can make them into stickers and stuff like that. But if you look at the actual image quality, it's horrific. Yeah. It's the last thing you would have wanted if you were, trying out a new film or paper way back in the day.
Yeah, the capabilities of digital offered some real timely results, and people used them and wanted them in a timely manner. So they discounted the quality aspect of it in many of the applications they found.
Something I'm curious about, and I've heard all kinds of numbers, and that is, at what point does digital imaging equal the image quality of film? And when I say film, let's say Kodachrome 64 is a standard, which for color was as good as it ever got for Kodak. What do you need from a sensor as far as megapixels to equal the resolving power and the latitude of a Kodachrome slide in a digital camera? What number would you throw out?
Boy, this conversation took place for decades inside of Kodak. And it was like talking about religion, It was so hard to pin down because there was always some aspect of image quality that you might emphasize more than some other aspects of it. And the first time that Kodak really had to decide that question in a product was when they came up with Photo CD. And when Photo CD, they had to decide on what kind of a resolution can we digitize an image and it'd be good enough for a 3R print. And they decided on about 6 million pixels. Okay, that was the highest resolution. If you remember Photo CD, it was a CD where you would take your film camera, get the film developed, and then they would scan it and put it on a CD.
Yes.
And they put it on several resolutions, okay? And they did do compression on there, but it was lossless compression. And they basically didn't lose anything with it. So 6 million pixels was the corporate answer. They didn't go around, make a big paper about it or anything. But that was the first time I actually saw them commercialize that answer. Now, I don't think they were trying to duplicate Kodachrome 64. Okay, so I think Kodachrome 64 would be a higher number. But, I've gotten in so much trouble in different arguments about this that I'm hesitant to give you a number right now about what that is. But if you're a photographer that deals with high quality images, you probably already have your own answer. The good news is you probably can get it today. So,
Steve, I want to shift focus a little bit and talk about the various aspects of your career at Kodak. I mean, you started in the research lab, but later on you had roles as a PR spokesperson and then in patent litigation. Can you talk a little bit about that, especially with the idea of career reinvention in today's world?
I was into product development most of my career. But in 2001, I was recognized along with Jim McGarvey and Ken Peralsky, who was another really innovative scientist that had lots of patents in terms of digital camera technology. We were honored as pioneers for the digital camera inside of Kodak, and then we started getting some notoriety outside of Kodak. And then Kodak started leveraging the first camera and the prototype. And so that's how I got into the PR business. They wanted me to go around. And I didn't know anything about public relations. They sent me to school. They sent me down to Ketchum, down in New York City, to take lessons about how to talk to the press. And they sent me on a kind of a worldwide tour of Australia and China and Hong Kong, all places, to talk about this. And I guess it was a good way to get media attention by talking about the first digital camera, and then they could talk about the camera they were introducing at the time. Mm-hmm. So that's how I got into the PR business. And it was interesting. I got to travel a lot and meet a lot of neat people. But I'm not a natural PR person, but I got a lot of experience doing it. So that was kind of fun. But here was an interesting thing. Kodak had developed a lot of intellectual property around digital photography and the architectures. And this is not just cameras. This is also in computer programs and image processing and things like that. And so we had quite a big portfolio. But Kodak traditionally was never offensive with their patents. The silver halide photographic world was dominated by a handful of people. And as you might expect, if Fuji had a problem with Kodak or an intellectual property issue, they would call them up and they'd go for a beer and they'd work it out. And that's the impression I had. But when we got into the electronic world, there were many different players and they were used to a much more aggressive form of intellectual property. So they came to Kodak. And we were in the consumer photography business. Now, this is in the late 1990s. And they started asserting patents against us, saying you have to pay us royalties because you're using our invention. So Kodak then took just some of the patents off the shelf and said, not true. And, they came on Monday saying that we owed them money. And by Friday, they were paying us. So we realized that we had this fundamental technology. And it's not a surprise. Kodak had spent hundreds of millions, if not billions of dollars in R&D research on digital photography. They just never told anybody about it. And so we had set this intellectual property position up, but we wasn't sure what to do with it. After these early experiences, they started a program where they were now going to assert intellectual property against all these manufacturers of digital cameras. So they started up a whole new thing, and they contacted me for a position of being a project manager in charge of a litigation. Now, I know nothing about litigation, didn't know any lawyers, but they thought I would be a good person to head this up because, one, I had run big projects before, so I knew how to have project-type stuff being done. I knew technically a lot about the subject matter at issue in these cases. And in fact, my 107 patent was actually in the case. So they thought, well, that would be helpful. And the other reason is because when litigation attorneys call up people in R&D, the people in R&D do not return the phone call because no one wants to talk to a lawyer. But they would return my phone call because they knew me. So that's what they thought I would be useful for. So I got into this position and I learned a lot about patent litigation and licensing. And I was called upon eventually to testify in several International Trade Commission cases where we brought most of our early litigation against, big companies. These were cases against, the biggest electronic companies in the world. So my career sort of morphed into this other area. And I found it very interesting. It's not something that I found myself naturally inclined to do. But, you meet a whole bunch of different people that think differently than you. And I could bring something to the table, and I certainly learned a lot from them. So I enjoyed my last few years, even though I would have never predicted that.
Do you think it informed the scientific or research side of your thinking?
Yeah, I think it did. I didn't really know much about patents. First of all, patents were never a big desire of mine. I was always interested in turning out the product. But I did get patents. I probably had about 10 patents when I was at Kodak, all involved with digital imaging. But I never knew what you did with them. You put them on the wall or something. But then when I got involved with this, I actually saw how valuable they can be. And how carefully you have to protect it, and what's involved with a licensing negotiation as well as a patent litigation. I was intimately involved with patent litigation, and I was helping with discovery and being deposed many times by different lawyers from different companies. So I learned the other side of patent law and what happens when you get into it. Now, to be honest, Kodak made quite a bit of money off of their patents in the early 2000s. I would say they made a lot more money than they made maybe even making some of the products. So it was a successful patent licensing program that they had. I don't think anybody would question that. But, when I was involved with it, I worked with the attorneys. We sat in the rooms and we talked about claims and claim construction and things like that. And these are experiences I had never had before. And these patent lawyers were really smart people, and they had some skills that I kind of wish I had, So it was a good learning experience for me.
So since you've retired, you've spent time working with young people to promote the importance of creativity and innovation in STEM fields.
Yeah.
You've been a faculty member at the University of South Florida's Institute for Advanced Discovery and Innovation.
Yes.
And you're also involved with the Innovation Force at the National Inventors Hall of Fame.
Oh, yeah.
So what's your view of the current educational system for STEM?
Well, I don't think I'm holding a unique opinion here that we have to really start to work on STEM education and get it more attractive to people. And I think one of the challenges faced by young people today is they're afraid to fail. And as an inventor or an entrepreneur or anyone trying to plow new ground, you're going to fail. But I think sometimes our educational process tends to emphasize efficiency rather than the learning. So when I see young people, I try to encourage them to try things because of the possibility, not betting on the probability of success. And so when you're with young people, especially in the National Inventors Hall of Fame, they have a thing called Camp Invention, which is a summer camp for students all over the United States. And they have a week-long program where students are there, and they're fifth graders, sixth graders, younger and older, and they do projects. And when you go and you sit with them, you can see that their creativity is all over the place, and you want them not to rein it in and be afraid of, so this might not work, so therefore I won't try it. You want them to keep trying things, okay? Don't be afraid of failure. You learn from failure, and that's something I don't think gets emphasized enough because our education tends to try to emphasize the efficiency of absorbing things as opposed to just the experimental nature of trying things.
I think that those are very good points. And something else that came to mind listening to you talk is the fact that, and maybe it's my default knee-jerk way of thinking about things, but you think of engineering as not a creative endeavor, that it's not like art or photography where you are, quote-unquote, creating. But the fact of the matter is, over your career, you have done a lot of creating in a different perspective, where you're taking these little objects, these concepts, these theories, and taking them to another place and making them do things that they may not have been originally intended to do. And that's very much of a creative endeavor right there.
Oh, there's creativity in all occupations and especially in the sciences and the technology. That's why STEM, I think, is an important area to emphasize the creativity part. And you just can't be afraid of being wrong. That's how you learn. You're correct. Sometimes people think of, well, you're in a creative discipline like art or music and things like that. And they certainly are. But there's a lot of creativity in the technology development, just about anything. Sometimes it takes a little bit to see the creativity because you have to sort of know a lot about it. But, some of the biggest joys I've ever had is seeing how other people solve problems. It's like, wow, that's really clever. I wish I'd thought of that, I'm sure songwriters say the same thing. They probably hear a song and say, boy, I wish I wrote that, It's the same thing.
Yeah, you can learn a lot from other people's mistakes.
Well, yeah, and their successes. Yeah.
So from your perspective as an inventor, What do you think we should expect to see happening over the next 10 to 20 years? What are you excited about?
Boy, I am just astounded. It's hard to keep up. Do you have a hard time? I have a hard time keeping up with this stuff because it is just so incredible. My daughter is an infectious disease fellow at the University of Virginia. And so my biological education was really bad. As a kid, I was just interested in electronics, right? But I'm trying to learn more about this. And boy, the things that are going on in the medical field, for example, just because of my exposure to my daughter's work is incredible. This work that's going on with the genome and CRISPR and things like that, where they can go in and tailor the genome to add or remove different bases to either cure a disease or make something happen. I just find that absolutely fascinating, and it's going to impact us all at some point, and that work is like 10, 11 years old. It just started 10 or 11 years ago. Not to mention AI, which is another thing that's just last November, ChatGPT with 3.5 coming out. That was like a revolution. In fact, it's funny. I get asked sometimes to talk at business schools about innovation. And one of the things they talk about is the AI revolution, where Microsoft's investment in ChatGPT was a significant investment, and Google seemed to be left out of it. I think perhaps I could guess what was going on in Google's headquarters when ChatGPT announced that. Because obviously having a very smart engine that could look up answers or compose answers for you is going to impact the business model for search engines. And I think Google was probably doing a lot of research, just like Kodak did a lot of research. They just didn't see how this answer was going to help in their present business model. They have to evolve the business model.
Yeah.
And so the story of Kodak, I think, sort of got repeated a little bit with the ChatGPT announcement. And
it's almost a perfect analogy.
It is, because I'm sure they spent billions of dollars in AI. They're not dumb. They know about it. But they weren't prepared to launch it and go forward as quickly as...
Because they don't like the answer.
But, if you're going to put it into Bing, who uses Bing, right? Okay, so we're going to put it in there, and now people use it. So to me, it's the same story unfolding, different technology, different times. But it's the same story of an established organization or established enterprise comfortable with something.
With a monopoly.
Long history of being successful, established business model, and all of a sudden, everything shakes up, and it's not just the technology. It's the way people are going to use it. It's the business model, and are we ready for that? So the Kodak story is just an example of something I think that's happening today. But anyway, that's just two of the technologies that I find absolutely fascinating.
Yeah, that's such an interesting comparison and a great way to sum up this chat. Alan, do you have any further thoughts?
Yeah, we've covered so much. The only thing I could think of, would you have any idea what the winning lotto numbers are tonight? That's the only question I have left on my list. It's at the very bottom, but if you have the numbers, I'll give them a shot.
Yeah, I know. Well, let me tell you, I have no idea.
But okay, on a little simpler thing. Okay, any interesting projects that you're working on right now, aside from anything we might have already spoken about, things that you're working on personally that you're kind of juiced about?
I'm not working in research anymore, but doing stuff. Yeah. It's funny how I like to learn things. It's like I always, when you're younger, you always say, I'm going to learn about that someday, right? Well, my someday is now. Okay. I have to generate that. So I've been a guitar player most of my life, and, but not a very good one. In fact, kind of a bad one. And so I'm learning more about music theory and how things I've been doing on the guitar. Now I'm finding out why I do them. Right. And so little things like that, right? And I also try to learn more about what's going on in the photography world as well. There's so much going on there too, I'm just amazed at what they can do with these cameras in these phones. I can't believe the volume and power requirements and the cameras that they're putting in there is just astounding to me. I would have never guessed. They used to ask me, when do I think? I thought in my lifetime we'd get to 2 or 3 million pixels. That would be it, kind of a thing. I can't believe what's going on now. So there's many things that I'm involved with that I'm trying to learn more about. And I mentioned the biology and the AI stuff, trying to learn about that as well. But it's hard to keep up with all this stuff.
I would imagine with your background, The iPhone must be, like you're saying, those mind-boggling device that mankind has ever come up with based on what you have been spending your last X amount of decades doing. To hold one of these in your hand and see what it does must just be mind-boggling.
It is. I am just astounded at the technologies that they put into these things. Didn't the last iPhone come out with a 48 megapixel imager? I think the last one did.
Yeah,
And I'm going,
yeah.
what? Well, first of all, who needs 48 megapixels, right? But to me, I just said, how the heck are they doing that on a die that size? And then they've got 3 of them in there. And it's like amazing. And that's just a very small part of the technology that's all wrapped up in that device we call a smartphone.
Yeah.
It's incredible. I'm just in awe of it.
And Kodak never, ever made a camera that you can make a telephone call with, ever.
Well, actually, that's an interesting story. Motorola did come to us for putting a camera in their early phones. And I wasn't involved with this, but I knew some guys that were, because there was a lot of frustration on the part of a lot of the people inside of Kodak, because they came to us and they asked us to come up with a camera module that would fit into their phone. And their requirements, as I remember it now, this is secondhand, but I remember they basically gave power requirements and a volume requirement, right? And so we wanted to make a camera that would take good pictures. Well, they could care less if the pictures were good. They just wanted it to fit and work. Mm-hmm. So they could call it a feature. And we wanted to run all these algorithms and make it pretty and stuff like that. Again, we had a culture clash there. We can't put our name or associate it with anything less than the best we can do. And Motorola, I think it was Motorola, was suggesting, we don't care. Just get it in there, and it's a feature. We can talk about it. We can improve it later, kind of a thing.
Good enough for government work. There you go.
Yeah. So Kodak did dabble in that stuff. I don't think they ever actually put anything out. Maybe much later they did in something with a camera and a phone or something, but I don't think they actually played in that field too much.
Gotcha.
Steve, one more question. Any plans for a memoir? You're such a good storyteller, and
I agree.
You have, it's such a fascinating, deep story.
The story where you sketched out these demonstrations for these different parts of Kodak as they come into the laboratory's meeting room on that long table. It's just, that's a Hollywood scene right there. It was really evocative.
Yeah, that was... That was interesting. I wish I kept better notes.
Oh my God! But it's all in your head.
It's, when you live it, you can't forget it. But I remember we did in the spring of '76. We did have the first interdisciplinary talks about digital photography, transmitting images over telephone lines. How people would look at electronic photo albums. We talked about these things, and so I'd like to share that story because I want people to understand that Kodak didn't have their head in the sand about this. We were looking at this problem before anybody else was. We didn't like the answer, like I said before, but we were certainly considering it. By the way, I was never stopped from working on any of this. Even though management didn't necessarily like where we were heading with this, they never stopped us. They never shortchanged us. When we proposed different types of imaging in the early 80s and stuff, they listened. We didn't talk publicly about it, of course, but we were never stopped from investing in it. So, yeah, I've had a very interesting career. And it's interesting to have seen the development of this fundamental technology, which changed the way people relate to each other. In a sense, photography does that. And to watch it, go from just an idea and a crazy prototype to something that everybody in the world has got in their pocket right now. And so I'm very honored to have at least played a small part in that and to be around the people that played all the other parts that made this reality. So I'm lucky, but I wish I kept better notes.
Well, I think enough to have helped for anyone who still is unclear about the story of this power switch that happened in the 1990s and the early 2000s. I think the story is kind of simplified in people's minds as, Kodak, just their eye wasn't on the ball and they missed this opportunity. It's much more complex than that.
Yeah, it is. It was much more complex. I had the privilege to work with the smartest people in imaging in the world, and they were just a 5-digit extension away. And I never once in my career ever had anybody not try to answer my question about things. So it was a great place to work. And they did innovate in many of the things that we take for granted today in digital photography. They were first conceived and built at Kodak. But it was hard for the company to adapt to the changing desires on the part of the customer as well as the changing technology base. And that's a lesson probably for any company today.
Yeah. Absolutely.
You know, this could be a little segment at the end of each of our shows moving forward here. Steve, you can come on and tell us another story about Kodak. You've got a bunch. Like 60 Minutes had Andy Rooney. We could have you.
Oh.
You know,
Now, there's a comparison I can use right there.
Steve Sasson, it's been a real pleasure speaking with you, an honor speaking with you, quite honestly, if I may say so myself. You had a interesting seat in photographic history, and having you on the show sharing it has just been an absolute treat. A lot of people don't know about this end of photography and how the transition happened. I remember living through it. I remember going from film to digital, and it was traumatic in many ways. It was not easy for a lot of photographers, financially, technologically, and everything else. Yet here we are, and we have you to blame for it. So we'd like to thank you. One last thing I'll throw in here, and that is that in the late 1950s, growing up in Brooklyn, as you know, my father was a mechanic, and in World War II, he worked on aircraft. And I remember we went up on the roof of my building early one morning, and we watched as the first Boeing 707 took off from what was then Idlewild, now JFK.
Yeah.
And as it passed over our house, he looked up, and he just said to no one in particular, he goes, "They finally perfected the piston engine, and now it's obsolete." And I think about that with film cameras. It's the same story, you know. They got it down.
Oh, yeah.
And then they came out with digital, and here we are banging our heads against the wall again.
Absolutely. Absolutely. Film's a great technology. People seem to think I don't like film. I am in awe of film. When you try to replace a technology that's been established for 100 years, think about what a great thing film is. For a few pennies, you can get a piece of celluloid that can be stored for years, then put in a camera made by anybody, exposed for a few milliseconds, store latent images for possibly years, then developed by anybody, and then used to project or to print on paper or just to project it. And it's just for a few cents. There's no element in the digital imaging chain that comes close to the utility of a piece of film.
Right. It's all non-proprietary.
It's just amazing, you know. So let me tell you, we were aiming to replace film. It was not easy. It took a lifetime, 30 years, basically, to do that.
Well, I tell you, the way you just described film, I know people with deep pockets who could back us. And if you want to put together a proposal, maybe we can get this film thing up and running. You never know. You never know.
You don't want to use my name when it comes to film. That's not going to work.
Okay. Again, Steve, thank you so much for joining us. And it's been a pleasure speaking with you. And we're looking forward to see what the future brings for photography.
Okay.
And if we like it, thank you. And if we don't, we're going to blame you for it. That's all.
Fair
we'll leave
deal.
it at that.
Alan, thank you very much. It's my pleasure. Jill, thank you. All's well. And Mike, thank you very much for helping me set this thing up here. So.
All right. That's the wrap of another show. Steve, again, thank you so much for joining us. If you are a fan of the show, but not yet a subscriber, head on over to Apple Podcasts, Spotify, or wherever you get your podcasts, and click subscribe. You can also find us on the Explorer blog, where we post photos from our guests and show notes. And please join us on Facebook at the B&H Photography Podcast group, where you can share your favorite photos and comments about the show. I'm your host, Alan Weitz. Jill Waterman is our creative producer. Episodes are recorded, mixed, and edited by technical producer Mike Weinstein. Our executive producer is Jeremy Weiss, and our editorial director is Sean Steiner. On behalf of the whole gang, thank you so much for tuning in today.
Thanks to Audio-Technica for sponsoring this week's episode.